Okay, so hello. We've got we've got Aris here from SketchUp. My name is Adam Fairclough. I'm the Customer Success Manager for ElmTech in the UK and Ireland, with the distributor for SketchUp in the UK. So I work very closely with Aris, who very kindly did the webinar for us last week. We also distribute Enscape and Twinmotion and V-Ray, some other sort of supporting products for SketchUp. So Aris has asked me to come and do a workshop for you. Just a little bit about me. I come from a technology background. I worked for a company called Carl Zeiss, specializing in sort of light and lenses for about 10 years. Other things, I'm a photographer. If you want to come look at my Instagram, there we are, it's scrolling by. I'm going to crack on though, because I've got loads to, loads to cover. I won't go through all these. So today we're going to be looking at a few different bits and pieces. I think we had a kind of initial feedback session where we got some sort of thoughts about the direction where we want to go for this webinar, and what are the kind of pain points and the things that we maybe struggle with within Enscape. Lots of things to cover, but today we're going to focus primarily on how can we help you to get some sort of better, more natural looking outputs from Enscape. And this is going to be just talking about physically based rendering to begin with. So if you're not familiar with the term PBR, physically based rendering, it's a bit like BIM. It's a concept, it's an idea, it's a way of life, but it's the concept of using accurate or realistic lighting values with measured surface material properties. And this is going to be the first part of the presentation. Actually, it's just talking about pressing the wrong button, talking about one of the parts of SketchUp and Enscape that we will be interacting a lot with. And this is what we call albedo color, which is essentially choosing your color in SketchUp. This is in other places maybe called diffuse color, or maybe called base color. But mostly we'll be talking about albedo color. So we're going to be talking about some of the kind of common mistakes that people make when they're choosing colors, perhaps in SketchUp or in another program, or pulling textures from the internet to use within a model, and how those kind of translate into a physically based rendering engine like Enscape. So the two colors that we talk about mostly at kind of both ends of the scale are the very darkest materials that exist in the world, which in this case is kind of charcoal as the example we use here, and then fresh snow as the very brightest example. Now, typically if we asked an artist in SketchUp to produce something on screen that is the darkest possible thing that they can think of or they would see in the world, what tends to happen is we tend to get 0, 0, 0 in our RGB values here, or if we're working in HSB, 0 in our brightness or value section. Now, basically, this is something that doesn't really exist in the world. What we're actually doing when we are choosing our albedo or our color is we are instructing the lighting engine of Enscape in this case to determine how much light it's going to reflect back of different wavelengths. So if we actually use these values, we produce a material that essentially can reflect back no light at all. And this is something we don't actually see in the real world outside of kind of lab created materials, which you may have seen Vanta Black, but we've just got some normal black paint next to this lab created material that still actually reflects back a tiny amount of light, but it's not normal. Now, if we actually look at if we actually took a tool and measured the colors of actual charcoal, which charcoal is an interesting example actually, because I think language and kind of culture often kind of make us think about charcoal as being a kind of grey material, but it's actually one of the blackest things that we will commonly come across. If we actually measure that is around about 15% sort of brightness or value, if we're looking at this scale, or 40, 40, 40. So it's actually a little bit lighter than most people typically enter into the system. And this produces a few problems that we'll talk about. It will be represented like this, but you can imagine if we wanted to cast light and shadow across this, there would essentially be no difference. Whereas over on this side, we know that we can actually go darker. So we've got a little bit of overhead for it. But what we need to hold in your mind is that these sort of values here should be the lowest, darkest values that you should ever apply to a material within SketchUp. And that's whether it's a solid color like we are here, or whether it's even a photo texture. We need to make sure that it doesn't have any pure black information or black information that falls under these values here. Now, if we look at the other end of the scale and we look at a white and we ask somebody to represent the whitest thing they could possibly imagine. The example we usually use in PBR rendering is talking about fresh snow, because this is one of the brightest things that we come across in the real world. Again, artists will often pick, or computer artists will often pick 255, 255, 255, or 100% brightness for the white. And this produces some other problems. If we look at, again, an actual real life example of something that we come across in the real world, fresh snow, if we measure that, that's around about 90% on this scale here, around about 230, 230, 230. Because we're actually creating a material that's reflecting back 90% of the light that it receives, not 100% of the light that it receives. And what I kind of want you to hold in your mind there, that is the very, very extreme of the sort of brightest, whitest thing that you'll think about. If I'm maybe doing an interior and we're looking at doing, say, a gallery wall or something like that, an art gallery wall, a kind of everyday white is probably closer to 75 or 80%. I kind of hold in my mind that 80% as being a piece of white paper on a desk. This is a really common mistake that's often made, and this produces some problems that we'll talk about, which is to do with things looking flatter than you want them to. Now, in terms of our the range of albedo, so we're going to talk about these primarily in grayscale. So we can think about these in with saturation and hue in a little bit. Most materials in the world fall between this, or all materials pretty much fall between 15 and 90%. And these are our non-metal materials. Our dielectric materials. If we look at the metals, those all fall into a much brighter range of the scale, and there's fewer of those to deal with actually, so we'll talk about those a little bit more in a little bit. But what we generally find is that most materials that we come across on a day-to-day basis, and most of the things you'll be working with within a rendering package, if you're trying to create naturalistic imagery, will fall within 30 to 60% of that brightness scale. Which the RGB values are just there. Just for your own reference, really, if you are going away and looking up some of the common world values, Enscape and SketchUp use sRGB values. There's several different variations of how colours are presented to computers, and the one that we're using here is sRGB. There's just a few examples here of some kind of common materials. I'll send these out separately in a link for you, which we can use as just a kind of baseline reference to kind of help us align both our saturation and our brightness in the right way. But I tend to use these as just a guideline to make sure that I'm not doing anything too crazy. But if we have a look at some more colourful things, basically we can't really trust our eyes when it comes to colours. Human visual color perception is a massively complex subject, and we're really influenced by all manner of different things. But if we just look at the numbers, purely the numbers, if we remove the saturation from these colors here, what we will generally see is that most of these, most of the values here fall within quite a narrow range of each other. So these will all be kind of between 30 and 60%. So even as something that we might consider to be quite colourful. And this is something to consider as well as we're choosing the values or choosing the materials that we want to be using, is that they're probably darker than we thought they are. So essentially what we want to be doing is when we're choosing colours for materials within SketchUp or another package, we just need to consider that we are essentially compressing the range of tones that we're going to be using within the rendering engine, and this will give us better results. But just worth noting that humans, we're more sensitive to changes in the darker tones, so you'll generally find that you need to make smaller changes in terms of increasing the brightness of the very dark materials. And with the lighter materials, where we are actually a lot less sensitive to changes in terms of how we see, we quite easily make large changes. So if a value was at 100% or 90%, we could maybe take that down quite easily to 80, 70, 60, 50%, and that still will look like a light material to us. So those are just some kind of guidelines that I hold in my mind as I'm selecting things. Now, one thing that's just kind of good to understand is the differences between the way that SketchUp represents its shading and the way that Enscape represents its lighting. SketchUp, if we choose a color in SketchUp, it applies it essentially to the lightest material, and then it draws in separately, it draws in the shadows on top of that, so it makes it darker. But as we know, in the real world, everything is dark and we're adding light into it. Enscape behaves in that same way, where we're actually illuminating the world rather than artificially darkening it. So kind of in a nutshell, when we're choosing some colors, and we'll have a look at how we can apply this on a real model very shortly, black materials are never pure black. We want to kind of hold in our mind the darkest value we should ever be using is that 15%. We want to avoid very high value whites. So again, if we hold in our mind that 90% would be the brightest we would ever use, maybe 80% as a kind of paper white is more appropriate. And this is probably something that's useful to you if you're producing exteriors. I see quite a lot of external renders where they've maybe picked a value that is way too high, and it creates a huge amount of contrast and kind of looks a little bit harsh and not particularly natural. I mean, we know this about paint and we know this about color. I'm sure you know this when you're choosing materials for things, but we're used to seeing surfaces when they're lit. So when you're picking your colors in SketchUp, you're essentially picking the color when it's already got light on it. So we need to actually pick a color that is when light isn't on it, essentially. So we need to go darker, and we need to also desaturate it slightly. And this is going to give us a little bit of overhead for the lighting engine to do its magic and make things look kind of naturalistic. What I would say is be quite brave with this. If we've got this as an example, if this was the color that was chosen in SketchUp because it looked right in SketchUp, I would be quite happy to take sort of 10% off that original value. So I might just take 9 off it, and then with my brightness, you could quite easily hack that down to 60. And we know that actually when we render out the image, we've still got the opportunity to make post-processing adjustments in Photoshop or an image editor. If we create a realistic world that adheres better to the properties of real life, then with our virtual camera, we can take an image and we could go away and do the things that we would normally do. That's the correct way to do it, rather than trying to manipulate our materials and create artificial materials to try and get to a certain end result. Let's start with real materials and then post-process it after. So just a couple of images that I grabbed from the internet, just kind of make a couple of points about these. These two renders, very different interiors. I'm afraid I was struggling to find lots of good exterior renders actually. But we can see here that the one on the left has some of the problems that we've talked about. It's very, very contrasty, and many of the materials that are chosen are probably too saturated. And this is kind of contributing towards an image that maybe doesn't look quite right. On the right hand side, we've got another model where the geometry fundamentally isn't much different, but the sort of aesthetic that's been chosen for this particular image actually really lends itself really well to producing quite natural imagery. So we can see the very muted color tones. We can see the kind of grays rather than blacks. All of these things almost by coincidence help to produce an image that looks a little bit more natural. It's not to say that it's not without problems, but it's interesting that when we look at renders that we maybe think look quite natural, sometimes it's because that person was chasing a style rather than maybe deliberately being aware of what they were doing. So we need to consider these slightly more muted colors with our selection, and less contrast with the colors that we choose. So as just an example of this, gone ahead, it's sometimes fun just to be able to revisit old assets. So this is an asset that we downloaded. There was a SketchUp model, looked really great in SketchUp, looks all right in Enscape, but it has some of the problems that we talked about. So at the bottom here in particular, the tiles were really dark. The leather on the chair is really dark. The metal color that's been chosen here for this painted metal, really dark. And some of our white materials over here were too bright. And so I just took a little exercise. I went through every material in this model and made it kind of fit in with these guidelines I've given you there. Made the black colors a little bit brighter, so nothing is darker than that 15%. Bringing down at the top end some of the very white colors, and also desaturating some of the colors that have been chosen in the materials within SketchUp. And I think one of the things that really stood out for me here is that not only does this allow, we've now got materials that can reflect light back. Even this grey material here, this does reflect light back into the model. It actually lightens up our model in other places. But one of the places that really stood out for me is that we can see more natural diffuse shadows that we couldn't see before. They're either just being absorbed by the material altogether, or maybe weren't even being produced because the light wasn't being bounced around to them. So yeah, just before and after them. So that's a bit about choosing our colours. There's something kind of worthwhile noting here is in SketchUp, if you have drawn something and we have not applied a material to it and it is designated as using the default material, Enscape always treats that as being pure 100% white. So if you're just doing kind of basic kind of massing studies and maybe looking at shadows and things and working with the default material in SketchUp, things probably will look harsher and not as good as they possibly could do. So next thing up there, I've got to keep an eye on my time. Here we are. Yep. Yeah, everything is shiny, and we're going to have a look at a few of these things in kind of a live model very shortly. But one of the things that we need to consider with the materials that we're choosing is that sorry, my words aren't coming out now. One of the parameters that we have to control, which is part of a PBR system, it's not something where you need to consider necessarily the measured values of real world things, but we just need to be aware of actually what this value is doing. So we've got a scale of roughness. We can basically take any material in the world and we could polish it to the point where its surface is so perfectly uniform that any rays of light that are reflected from it bounce off in a very predictable way. And then if we do that, we get a kind of mirrored surface. Imagine if we take a lump of metal and we polish it, we get a mirror. At the other end of the scale, a rougher surface, and this is kind of microscopic level. So not necessarily a coarseness that you might feel from sandpaper, or not necessarily the wood grain that you would feel, but the even more microscopic detail than that. If the surface is irregular, it causes that light. It still reflects away, but it bounces away in multiple directions. And we can see that as we make the surface rougher, our reflections become less clear, more diffuse, to the point where the light or the reflections are essentially spread across the whole surface. And this happens with both non-metals and metals. And we can see that the kind of, even on this metal one here, we can see how we could maybe choose a material that perhaps represents a mirror simply by changing this, or perhaps a material that represents, I don't know, like an aluminium you might find on a MacBook or something like that. We can see how we can create different materials very easily with this particular adjustment. What's worth noting here is that everything in Enscape is treated as 90% rough unless we specify anything else. So we're going to have a look at this. Basically, everything in the real world is shiny to some extent, but by default, we won't see it in Enscape unless we ask for it. So just another example here. It's the same image before. I've gone through one stage of kind of correcting my albedo color ranges. Next thing I did was to make one change to every material in the model, which was to make every material 60% rough. Okay, so it might be a little bit over-egged on certain ones, it might be a little bit under-baked on other ones, but generally what we start to see is a scene that looks a bit more natural. Particularly that floor, I think that's the one that is really obvious. We will often see reflections on even quite things that we might consider to be so rough. We know that if you're outside on a road on a hot day, we can see reflections even on quite a coarse concrete. We can see it on painted walls. This is a mistake a lot of people working on interiors do, where they think I'm using a Faro and ball paint, which is very matte, in the scheme of paint, but actually reflects back quite a lot of the environment, and you'll see this all the time. So we can make some quite big broad stroke changes to the way our images look simply by bringing back some of the reflections that Enscape by default has chosen not to show. I'd like them to change that value as a default, but never mind. So let's look at this as well in the live model and see how we can combine some of these these kind of guidelines and theories to improve things. Right. My volume is all okay. Everyone can hear me fine. I should have asked that early on. I presume so. Guessing somebody would have said something. Just move this over here. Right, so let's just have a look at a couple of bits and pieces in Enscape. Before we go into it, I'll just talk you through a few bits that I tend to do with Enscape. Things I have turned on. I have my live updates and synchronized views turned on all the time. This is just going to keep Enscape and SketchUp totally in sync, and this will handle the field of view and a couple of our projection options correctly. I've got a little bar in the way of things that means I can't get to my settings. Oh, how can I deal with that? Anybody know how you hide this zoom bar? Anybody? Hide video panel, that one? No. Hide floating meeting controls. Ah, there we go, got it. Right, this is going to keep things in sync here. This will keep parallel projection perfectly aligned. If I rendered out this 2D image from SketchUp, rendered out a render from Enscape, those would remain exactly the same. Likewise, the same for perspective. I can render this out, I can render this out, I can overlay those in SketchUp in Photoshop or something, and those will align perfectly. A little bit more complicated with 2-point perspective. Unfortunately, Enscape doesn't recognize what SketchUp does. That's something that's being worked on, I believe, because that's been a request for quite a long time. There are ways to do it, so if you really need to know how to do that, send me an email and I'll talk you through the process to do it. But let's just have a look at our visual settings first of all. And I'm just going to talk through these a little bit because this is some of what we wanted to cover. Actually, was about just trying to get everybody on a kind of in a kind of level place for what they're doing with the Enscape setups. So I'm just going to reset it to default here, and we're just going to just talk through what these are and how we might use them. So the most important thing on this particular tab here, the screen that we're looking at, is the rendering quality. This not only affects the quality of what we're seeing during our real-time render. This also affects the final output quality when we hit render, which would be my button there. So if you aren't changing this to ultra before we actually export out an image, you're getting a worse image than you possibly could get. You'll actually be removing certain reflections, and you'll be removing actually one bounce of light from the model. So the lighting won't look as natural. So really important that you either keep it on ultra or you change it to ultra before we actually do a render. I generally leave auto exposure on if I'm just kind of doing basic stuff. If we're doing lighting setups and other things, we may switch that off and not let that interfere. Over in the image tab, this is all post-processing stuff. So this is stuff we can achieve in Photoshop, but it just allows us to achieve it in real time. I will generally be leaving all of these on default to begin with the exception of the effects. Bloom, which I don't want contaminating color by brightening up things that are too dark, or vice versa. Vignette, same thing. Chromatic aberration, it's fairly harmless, but we'll just start with a clean image. Over on atmosphere, I'm going to turn off my fog, which is on by default. I'm going to leave these ones all as they are. I'm actually going to turn off my artificial lights because I've placed some lights and I just want to rely on the sun and the diffuse lighting. Other bits you can see here, which are just useful to know about if we're kind of doing an initial setup. Your clouds do influence your model. So it's actually possible to block out the sun and we end up with just more diffuse lighting. So, I mean, this is going to be a little bit down to what it is you're trying to achieve. But I generally just turn off the clouds so my direct sun is still present. And our horizon options, these just allow us to set some things off in the distance there. You can leave those on. Those are useful if you've not got any actual physical context in your model. This will just provide some sort of interest in the reflections, I suppose. Stop things looking quite so computery. Likewise, it does influence the lighting that falls onto the side of the buildings, which I've accidentally left that brick on really shiny. So if you're wondering why that's shiny, that's why. That was an accident. Which makes me worried. I've also left some other things on that I need to show you. But I'm just going to stick with white ground for now. Over in the Capture tab, you've got the output resolution for when you hit render. This is also your aspect ratio. So if we're wanting something like a sort of typical camera photo, something like 3:2 is fairly typical. If you've got your save frame box ticked, when we actually hit render, you'll get your save frame, and it gives you the opportunity to reframe it if it's not quite right. The newest version of Enscape actually has a button that allows you to keep that on all the time, which is actually really useful. Other bits, obvious ones, portable network graphics, PNG, JPEG, however you want to output it. One thing that is worth noting, if you want to handle all of your post-processing, say in Photoshop afterwards, OpenEXR actually gives us a 32-bit image. If you're familiar with kind of photography, this is kind of Enscape's equivalent of a raw image. So if we're going to do more extensive stuff in Photoshop afterwards, you might want to export it in OpenEXR. I'm just going to leave it on JPEG for now with my ratio there. Now, just worth noting, if you didn't know this already, you can actually save this preset into your SketchUp project. So I can save it into my project. I'm just going to call it my default settings for now. Spell it right. And I can actually save that out as a file. I could send that to a colleague if it's not embedded in the model, or I could save it into a location on my computer and pull that into other models in future. What's quite useful about that is you can create multiple presets that you're able to switch between very easily. So I'm just going to pick that one for the sake of it being obvious to see. If I wanted to create a second preset that had different exposure or different fog or whatever, I can actually now just instantly switch between different presets. And this becomes increasingly important later on down the line, because you can actually attach a preset which controls your exposure and your post-processing and your bloom and your weather and all sorts of stuff. We can actually attach these to different scenes within Enscape. And that's useful if you're providing either real-time options, or you just want to send a project to a colleague and know that they're going to get the same visual preset that you were looking at when you were setting things up. Okay, let's go back to that one. Right. So I've actually stuffed myself over by making changes in my model, which I appear to have accidentally saved. Let me just check that everything is as it should be. Give us 1 second. No, we're okay there. So let's come back to the model here. Just give us 1 sec. I just want to put things back to how it was meant to be for my demonstration. So don't look at this. I'm going to put this back to how this model was when I first got it. There we go. That wasn't too hard. And pretend you didn't see that. Okay, so this is actually how this model had been prepared within SketchUp here, and we can see really nice model. For some reason, I made it float in the sea. Don't know why, just did. But we can see a couple of the problems that we've already talked about here is that when light is falling onto this building at certain times of day, we've actually got like a kind of Santorini vibe going on with it. And we can kind of see that from the SketchUp model, which was kind of provided as is, and we can see from the textures there, I can also see from reference photos of buildings very similar to this, that this doesn't look particularly as it should do. And I guess as architects, you will be choosing some of the materials yourself, so you would know how that material, how it should look in real life. What we can do in SketchUp actually is if we grab the color dropper tool and choose the material in SketchUp, and we come over to edit it, what SketchUp will actually do is it will take all of the values of the pixels from dark to light, and it will actually average them just here. And it's not done it again. the actual value for this should be on 80%, but for whatever reason, it's not taken. Let me just get this back to its default position. Sorry. It's because I ran through this before we did this to make sure that we were okay for time. And now I'm actually slowing myself down from doing that run through. Never mind. Right. What we're going to have to imagine is what we can see is when we've color dropped this, essentially, the brightness value should be the average of this here. And it should be 84%. 84, as we've talked about earlier, is actually brighter than a piece of white paper. So actually our brick is not a light colored brick. It is actually a white colored brick. And this is how the rendering agent is having to deal with it. And it might not necessarily look like a white colored brick because the auto exposure and other stuff is going crazy trying to deal with it, but it's actually causing kind of glitches in the way that lighting is rendered within our model. So we can actually change just within SketchUp itself, we can change the average brightness just by using the brightness scale. So I might actually decrease this down. Let's just to see what happens when I take it down to 80. It stayed the same. What I know is that I maybe need to make this darker to make a little bit more brick-like. So I'm going to bring this down to 60, which is kind of at the sort of higher end of that scale that I showed you earlier of kind of most or many materials. We can now see that, I suppose, even between SketchUp and Enscape, this kind of more easily reads as brick. And we can also see that as we're changing the lighting conditions across the model, this is kind of behaving in a reasonably natural way, and things are looking quite nice, even as they should do. What this has highlighted, though, as we've kind of brought the brick into a range of brightness that is more appropriate. So I'm just going to change that to daytime again. We can see that our concrete now looks abnormally white. Okay, and it doesn't necessarily look like that in SketchUp, but it does over in Enscape, and this is because somebody's chosen a value of color that's too bright. One really useful thing you can do as you're evaluating these models is that we can come into our visual settings. If you actually desaturate the model totally, we can see any particular colors that are sort of falling outside of some of those ranges. So that concrete especially is the really problematic one. So let's deal with this. Let's see how I left this one. That's not reading sorry, all the points I was going to make are gone. This by default was on 89. Okay, it's still there. Right, so if I color pick this without me interfering with it previously, this particular concrete would actually read 18 as an 89 value. And this is, as we talked about earlier, this is pretty much close to that 90%, that brightest value that kind of exists in the natural world, certainly. And this is reflecting back too much light. And I think you probably agree that this is not meant to be a white concrete that looks like snow. It's probably meant to be a white concrete that looks like a light grey colour. So I'm actually going to decrease the value of that material again to within a range that's more appropriate. I'm going to try just above that range. Actually, I'm going to take it down to 70, which is less white than paper, but maybe at the brighter end of the scale. I still think that's possibly a little bit lighter than I'd like it to be. I'm going to take it down to 60, and I think that's possibly could even be darker. But we can see we're now kind of better harmonized there. There's less kind of extreme contrast, and as the lighting conditions are changing, things are starting to look a little bit more natural. Let's head into an interior and just look at how we can apply some of these things inside as well. Right, so on my interior here, we can see a couple of things that really stand out. We can see these chairs look very, very, very red. Let's have a look at these and see actually what colour these are. Right, so we've got not only a material, we've got a material base that is reflecting 100% of all red wavelength, that's something else, wavelength light, and producing a super saturated red that is super bright. And again, we can see this if we actually take the saturation off again. those chairs are, are white if we look at them in grayscale. So like tonally they sit, they're too contrasting. Though that's essentially an impossible red. So we're going to start off first of all just by taking off some of the saturation. Rule of thumb, take 10% off the value that was there originally. So I'm going to again take that down to 90. And for my brightness, I still want this to be fairly vivid. So I'm going to go down to say 70 for this. Okay, and we can see even just here, these chairs that are in the shade versus the chairs that are in the light, everything's kind of looking a little bit more natural. I think so. I hope you agree. And we can see that our chair over here, which by the way I've left accidentally glossy when I didn't mean to, is responding better to the light compared to actually what it looked like a minute ago, where actually the color was actually being sucked out by the engine not knowing how to deal with that 100% saturated red. Let's put that back to where we were. What did I say? So interestingly, our chairs look more colorful by reducing the brightness there. So there's a couple of changes there. Let's have a look at the tables here. So these are some darker surfaces. And what we can see here is we've got a black material, which you can just about see. Auto exposure should lighten that up. I don't know how clear this comes across on Zoom, to be honest. But if we actually just look at the numbers, this average black value is 2. And as we said, charcoal, the darkest material that we come across, is closer to 15 or 16. So we need to deal with this. And my model's just auto-saving, so I can't do anything. All right, there we go. So I'm just going to take that to 16. It doesn't make an immediate difference on the screen, but again, I will expect this to behave better across different lighting conditions. And we have to consider I've not actually placed any lights on the interior just yet. If I look at the table legs, they're not so bad. They're on 14, so they're on the sort of darker side, but maybe I'll just take those up a little bit. Maybe the person who's chosen 14 had wanted those to be a kind of dark grey rather than a black, so maybe I'll take that up to 25. And what we can see here is that now we've actually retrieved some of the detail that has been lost into the materials which were sucking up all the black light. So we can kind of go through the model doing this kind of thing. I suppose the other one that we might consider is the floor here, which kind of falls within a normal range. I mean, whoever created it would have an idea as to whether that's meant to be a dark grey or a lighter grey, but we'll leave that one alone. So let's have a look at how we can control the materials. This is coming back to the roughness scale. And this is something we can use to very quickly make changes to our materials. This might also explain why some of you had problems with the difference between the way Enscape seemed to look for you in SketchUp and some of you saying it looked different in Revit. There's two different ways that we can control materials in Enscape. This is the basic way. SketchUp supports both, or Enscape for SketchUp supports both this simple way and a more sophisticated manual way. I think Revit only supports this basic way at the moment. So not here to talk about Revit, but this might explain why some of the things that you've experienced might be happening. Basically, what Enscape is doing is looking for keywords in the names of the material. So this particular material here, which is a glass, it's come straight from SketchUp. It's called translucent grey glass grey. And Enscape's seen that it's glass and it's applied some glass-like properties to it. It's given it a reflective surface, it's made it transparent, and it's applied a couple of other physical-based properties to it. Within SketchUp itself, we can actually adjust the opacity of the glass, and we can actually remove the opacity altogether if we wanted. Worth noting, any material that you use in SketchUp that has less than 95% opacity, Enscape will also assume is glass. So if you've got any kind of transparent trees, for example, that you've used as context, or silhouettes as or scale figures, those kinds of things, those will start looking really bizarre in Enscape, and that's because Enscape's thinking they're made of glass. Let's have a look at some of the other properties we can change. If we have a look at this material here, there's a keyword here, mirror and chrome. Basically, any material that has mirror or chrome in the title, Enscape's going to apply a metallic finish, and it's going to make it 0 roughness. So it's going to make it very shiny, so we get a very highly polished surface. This can be influenced by the base color, but we'll look at that on the next one. If we look at the metal tag, we've got 4 tags there: metal, steel, copper, aluminium. These all do the same things, although we might in our mind think of those as being different materials themselves. This will apply a metallic finish with a rougher surface. We see the difference there. Steel, copper, aluminium will all do exactly the same thing. If we're actually wanting to change the color of our metal, that is controlled by our albedo, by the color that has been selected. And in one of the slides earlier, I had the actual measured values for gold, silver, titanium, cobalt, all the other ones there. So you can change this, and you'll see it changing there. We're going to move on to another material here, another material type. This is a slightly more complex one. And this is the polished shader that Enscape uses. So there's 2 variations of this. We've got 2 keywords here, polished and acryl. These will essentially apply a transparent layer onto the top of our base material. It will actually apply a roughness value to the material, and then it will apply a shiny lacquer on top of it. So that can be useful to produce varnished surfaces. That can also be useful if you want to produce, say, an enamel surface or a painted enamel surface. There are 2 variations on this as well. We've got one other variation, sorry, we've got clear coat and car paint. These actually turn on metallic property and will allow us to create a metallic paint, essentially, with a clear lacquer on top of it. So primarily designed for cars. That's a really common usage for it. We see the kind of effect that we get there. Let's move on to some of the more common ones. Let's have a look at some of the things that Enscape's looking at. So I wouldn't get too hung up on the actual tags themselves and actually what they're named. But ceramic here, we've got if we use a ceramic in the title of the material, it's going to apply, I think this is a 10% roughness to the material. Some dogs going crazy outside. I don't know if we can hear that. It's applied a 10% roughness to this. Marble is going to produce a slightly more rough surface, a slightly more diffuse reflection. Oh, I've typed the word rough instead of marble. The dogs are roughing outside. There we go. Marble, we see here there's a difference in the sort of level of sheen, and those are really versatile tags. If you want a kind of shinier surface, just you can type ceramic on it. If we want a slightly more diffuse surface, marble's really good for that. Over on the other ones here, plastic. Plastic will give us I think it's around about 50% roughness. And we can see now that we've just got a very light sheen on top of this. So we can make some quite dramatic changes. I'm not going to bother with fabric because it just pretty much looks the same. Very rough. It's sort of 80% roughness, so really close to the default roughness. Default roughness is at the top there. So we can see here our materials actually are sitting in the world better, even these 3 basic ones, just by having some reflection applied to them, or some glossiness or lack of roughness applied to them. And we can use this to our advantage to have really quick, big impacts to our models. So if I was to, again, make some really large changes to the model, let's just move over here. I could grab my floor and I could, for example, type marble. It's not made of marble, but it's going to apply a little bit of extra reflection. My chairs have already got something applied to it. The leaves on my tree, I've already done a bunch of this stuff, so I can't show it to you. But let's have a look at something else instead. I've got my ceiling there. We can do something there. Let's do something on the ceiling. It's polished concrete apparently. But if we try, let's try marble, see what it does. It does nothing because I think I've broken it. Right, let's come back to this. But as we saw in the screenshot I showed you a little bit earlier, oh no, I've pressed something. Put collaboration mode on. Let's come over to look at controlling these materials manually. Because I think I've got time. I have good. Even I keep fluffing things up. We're doing okay for time. So I've just got a material ball here. And what I'm going to do is I'm just going to grab this. Oh, I have to grab it here, don't I? Sorry. Oh, I just realised I'm using my trackpad. I've got a mouse plugged in. Noob. Let's do that there. Right. Just see what material I've got on here first of all. Default material, handy. Okay, so we can take full control over some other properties of the materials. And we can do this with the material editor, which you have available to you for Enscape and SketchUp. This isn't available in all versions of Enscape, but it's there for SketchUp. And this is going to bring up a little window here. You may or may not have seen this before. And this is a list of all the materials that exist. So in this case here, this one here is called matte ball, default material. It will automatically show you the one that you got selected in SketchUp anyway. But if you've really organized, you might be able to see some of the materials there. And we can do the basic stuff we've talked about. So we can change the base color of the material. That will actually sync up with SketchUp if I probably click somewhere. Yeah, you see it changing there. Auto-saving again. I should have turned that off really, shouldn't I? That autosave has caused me all manner of problems today, it seems. Get back to my editor. You can change the basic stuff, our base color, our albedo. We're going to have a look at a couple of other options. We can see actually, first of all, the reflection control. So we can take full control over how reflective that surface is. And we can see Enscape is reflecting very nicely. We can essentially eyeball whether something needs to be glossier or shiny. As we said, generally I find that I need things to be under kind of 70% to kind of make a difference. As we showed in that other screenshot previously, everything was set to 60%, and even concrete and brick will have a good degree of shininess to them. And actually the roughness that you're seeing actually comes from kind of coarser details within the material, which we won't be talking about today, but we'll look at another time. So our roughness slider, this is based on science, but you are able to choose this as best suits you, or maybe apply a different material there. Let's make an impossible black, just so, you can see how it breaks when we do an impossible color. Excuse me. Right, so other settings we might want to know about. Metallic. This is a slider, but in reality, there are only two types of objects really in the world. Metal, so you want it on 100 if it's made of metal, 0 if it's not made of metal. That is part of the PBR theory. Just want it on or you just want it off. Don't try to do in-between ones, even if you think it looks right, because it'll probably just look weird at some point under some lighting somewhere else. Our other values we can change are our specular value, which again don't need to change. Most materials in the world sit between 40 and 50% on this scale, like 98% of the material, so it's almost not worth touching. Some other bits we can change. We've got our transparency option, and this is what oh no, my ball is not double-sided. I've got some weirdness going on here. Give us 1 sec, let's just make a bit of plate glass quickly. I've prepared so much for today, and of course, never works out the way you want it to. So I've got a glass material here, and we have control over the opacity, which you can primarily just do with the opacity slider. That's going to be somewhere for a typical kind of clear glass between 8 and 13% is about normal. Obviously, if you're using other kinds of tinted glasses or glasses to reduce heat, then that opacity is going to be lower. You might find in order to make it read better, you may also want to apply a tint. And you can do this not with the base color, but with this tint option that it offers you here. And the tint option, you can do colored tints if you wish. You can essentially adjust the intensity of that tint by changing the color. So I might do it, say there. Refractive index. Most things in the world should default to 1.5. Most glass will be between 1.34, 1.49. Enscape actually treats it slightly differently for plate glass as it does to item glass, so that kind of thing. You'll see it kind of creates that bending of light on the curved edges, almost like a double wall effect. Does that there. You can, if you're using curved objects, you might want to use that to your advantage to maybe give it the perception of thickness, but it's not going to have any effect on sheet glass. One thing worth noting in regards to glass is that Enscape does not like having multiple pieces of glass in front of each other. So if you've got a window or a frame or something that's come through with actual double glazing or triple glazing geometry on it, you may find you get some weird effects happen. So I think here's a good example of that. There we go. And that's got double glazing on it. My water is disappearing when I look through the glass. I'm not sure if that's a bug or if that's a technical limitation. It may well be the latter. Just something to be aware of. If you can remove any additional sheets of glass from your model in certain places, you're going to get better results. The other option just worth noting there is there is an option for frosted glass. And what this will do is this will frost the glass, but only if you adjust the roughness slider. There goes my autosave again. Eating into my time, 15 seconds at a time. Quick, I'll have a sip of my coffee whilst it does that. You can see here that we can frost the glass, and that's by controlling that roughness, and that generally works okay up until about 60%, and it sometimes goes a bit wrong, but again, we can get some really nice effects there if you needed to create kind of privacy screens or whatever. Other bits that we can change that are useful for you to know about is, let's have a look at, I think I've got it applied actually. Let's come into the tree, plant. We've got 3 minutes left now. Let's have a look. So cast some sun over the plant there. And if I just turn it off to begin with, because this usually isn't on by default. There is a tag called, there's a type of material called foliage. And what the foliage material does, it allows for, and you can see it here, it allows for light that's hitting one side of this leaf to essentially transmit through to the other side of the leaf. If your material has the word leaf or foliage, it will apply that automatically. But if you want to turn it on manually, we can turn it on just like so. And this is just going to help shadows and light cast better on both sides of a leaf, and it will light it up. You can also use that for other places. So if we come over to that glass again, let's just make that papery kind of material, single face. If we apply the foliage tag to this one, come on. Can I cast a shadow onto it? So your shadows that hit from one side will pass through onto the other side. So you can get some nice kind of, I don't know, like paper lantern types effect with that foliage tag. So you don't just need to use that for foliage, you can use that to create screening and other things. Net curtains are something that can really benefit from that because it will just allow the light to pass through ever so slightly. The other materials are pretty self-explanatory and we won't talk about those. But the clear coat one, I suppose, is just what we saw there. Previously, we've got the option for changing the roughness. Let's make it lighter so you probably can't see it very well. We've got the option for a metallic clear coat or a non-metallic clear coat. The roughness slider will adjust the roughness of the material that sits under the shiny lacquer. So there'll always be a certain type of sheen to it, which is provided by the coating, but the material underneath itself may actually be rougher. So that's another way that we can control those manually. So you can often kind of nip through your materials, making some quite, rough changes, no pun intended there, just by adjusting the roughness slider. And you can see at the very extreme, if we make, say, this floor almost mirror-like, how there's a certain quality of realism that perhaps wasn't there before. I mean, it's kind of unreal. But what this provides into our model is extra variability and extra almost imperfection that we struggle to achieve in computer imagery, because the edges of geometry are so sharp, our lighting is all perfectly aligned in a grid. This will just allow for light to bounce around in a slightly chaotic way and produce something that looks closer to that of real life, and really can contribute towards helping things to look better. So that's pretty much all the things we wanted to talk about today. I'm going to head back to my slide that says, yeah, thanks. But I'm pretty much finished. Oh yeah, there's that picture there. We've applied a roughness. I've also applied some lights in here, taken this into Photoshop and just done some basic post-processing. We've got something that looks quite significantly different to that original image that we saw, just by following some of the things that we've shown today. Right, that's enough of me talking for just this second. I know we're at an hour now. I just made it despite some little errors there. And of course, if you need to go, so you've got an hour, thank you for watching. But there's an opportunity, if anybody has any questions about anything we've just talked about there, or anything else that I can answer for you, I am willing to hang around longer.